Today, on how it's made. Kelp caviar. Luxury sailboats. Dental crowns. And high-performance engines. Caviar is made by processing the unfertilized eggs of certain species of fish. For those who love the taste but not the price, there's simulated caviar made of kelp, a type of seaweed. A fraction of the cost, it looks, smells, and tastes similar to the real thing. Unlike fish caviar, the source of kelp caviar is a plant, so it's fat-free, cholesterol-free, and has 0 calories. This company makes its kelp caviar plain, which is vegetarian, as well as in several flavors. Kelp is chock full of vitamins and minerals, and is especially rich in iodine. Being a marine plant, it's quite different from land plants in that its consistency is gelatinous, which makes it ideal for producing little rubbery balls that resemble fish eggs. At the kelp caviar factory, they begin production with kelp that's been dried naturally, then ground into a fine powder. The other ingredients are salt, citric acid, and if they're making a flavored variety, natural flavoring in liquid form. They add the ingredients one at a time to water. The mixer blends them thoroughly for about an hour, producing a thick, gelatinous liquid. They transfer the mixture into a pot, connected to an extrusion machine. The machine pumps the mixture through what looks like a shower head. Only instead of outputting a steady stream, it squeezes out droplets, producing tiny kelp balls called pearls, which look exactly like fish eggs. The pearls drop into a coagulation solution. Besides providing a soft landing, this solution helps hold the pearl's shape. The pearls roll down a chute into waiting containers. The water drains out the bottom. Workers empty the containers into large colanders. Then they rinse and strain the pearls to ensure they're all a certain minimum size. Pearls that are too small simply fall through the colander's holes. They weigh out a specific quantity and mix in an all-natural stabilizer required to maintain the pearl's texture and round shape. The factory's quality control lab tests a sample from the batch to make sure the pH level is just right. Careful pH control, coupled with pasteurization, is why this product doesn't require any preservatives. At the packaging station, workers fill glass jars, then twist a tin lid onto each one. Then the jars go into a pasteurization machine. It heats the caviar to a high temperature for a specific period of time, which kills off any bacteria. This ensures a 2-year shelf life without refrigeration. Once opened, the product stays fresh in the fridge for 3 months. After printing each lid with a lot number for tracking purposes, all that's left to do is dress the jar in a cardboard label. Kelp caviar contains no artificial colors or flavors. Unlike certain types of caviar, it doesn't bleed color to the surrounding food, even when baked. And while real caviar is typically either black sturgeon roe or red salmon roe, kelp caviar comes in additional flavors, such as truffle, cognac, and wasabi. Luxury sailboats evoke thoughts of freedom and sunsets on the ocean. But in the factory, it's all about hard work, because luxury sailboats are still mostly made by hand. Just a few hundred units are produced every year, each boat requiring up to 3,000 hours of work. Sailboats have come a long way since they were first used on the Nile River some 6,000 years ago. These luxury sailboats are designed using computer-aided design software, which allows the engineers to optimize the hull shape for stability and speed before actually building the boat. They build the hull from fiberglass, which comes as knitted fabric, and as mats of random strands pressed together. These two layers are hybridized to form a light but very strong material. Huge molds are used to build the hull of this 45-foot boat. Workers unroll the fiberglass and spray it with resin. Then they unroll the next layer of fiberglass, which overlaps the previous one, making for a very strong construction. The resin hardens as it cures. Boat parts are so large and heavy that they must be moved with cranes. This part is called the transom. It will be attached to the hull with fiberglass, while it and the hull are still in the molds, creating what's called a monocoque construction. This hull surface will receive the structural grid, which will support the engine, mast, fuel tank, and water tanks. Meanwhile, carpenters fashion the wood components. This door is made of solid teak, a durable hardwood that doesn't rot. The wood parts are then put into a curing oven at 50 degrees Celsius. Air is circulated to cure the varnish in about 11 minutes. Bright lights also help cure the varnish. It's time to put the divisions in place. The hull liner has slots designed to receive the various wood components. Each part is fitted twice, first to check the fit, then permanently with high-strength adhesive. It's time to install the engine. With its 54 horsepower, the boat can cruise at 8 knots, even when the wind isn't blowing. This stainless steel structure serves to reinforce the rudder. It's attached with epoxy glue. After closing the rudder mold, they insert a paper cone to completely fill the rudder with urethane foam. The foam expands as it cures. They finish by carefully sanding the edges of the rudder, which is now attached underneath the hull. To build the boat's deck, molds for the top and bottom parts must be aligned. High-strength bonding material is applied at specific spots. The two molds are carefully fitted together. When the parts are perfectly joined, the mold is removed. The deck is now ready to be fitted on the boat. Workers carefully line everything up. Luxury sailboats have enough space for many rooms. and can be customized with appliances and electronics that suit the customer's needs and tastes. All that's needed now is a dip in the test pool for a check of the engine, generator, and other mechanical systems. After about 3 months of hard work, the boat is now ready to set sail for offshore adventures. Dental work dates back to ancient Egypt, when people used animal teeth and pieces of bone to replace their own teeth. It couldn't have been pretty. But today, high-tech dental crowns can transform damaged teeth into pearly whites that look just like all the rest. A dental crown starts with a plaster impression of the mouth. It goes to a laboratory where they cut it into segments to isolate the tooth in need of restoration. They scan it into a computer and send the dimensions electronically to the factory. There, machinery pumps liquid plaster into molds to create cylinders called blanks. The plaster blanks take about 10 minutes to harden, then move on to cure for an additional 12 hours. At the next station, a robot installs a blank in a milling machine. A computerized cutting tool sculpts the blank, guided by the scanned data of the plaster replica. It makes a duplicate that's 20 to 30% larger to allow for material shrinkage later in production. Next, a device dips the plaster tooth in liquid ceramic, which hardens into a non-stick glaze. The next robot orients the tooth, along with several others, in a circular holder ready for the next phase of production. Nozzles funnel ceramic powder into molds arranged in a matching circular configuration. A robot then inserts the tooth replicas in the corresponding molds. A worker stacks several of the mold platters and threads them together with a metal rod. He transfers the rack of mold platters to the next worker, who plunges it into a water-filled chamber. He closes the lid and activates a pressurizing system. As the liquid pressurizes, it compresses the ceramic powder, solidifying it. This process takes just 10 minutes. Another automated tool now chisels away the excess ceramic, following the profile of the plaster tooth replica that's still inside. This creates the ceramic shell of the dental crown, called the coping. It's removed from the plaster replica thanks to the non-stick glaze. Baking the coping at a very high temperature toughens the ceramic. It also shrinks the crown shell to the final size. They carve a plastic copy of the tooth using the same data scanned into the computer earlier. They use this plastic replica to test the fit of the ceramic one. A technician inspects the ceramic for chips or cracks, then packages it for shipping. This tooth-like shell is now on its way to the laboratory, where it will get the finishing touches that will transform it into a crown. When it arrives at the lab, a technician paints several layers of porcelain onto it. The color will change to a more realistic hue once they fire it in a special furnace. The furnace pumps out air or other gases that would hinder the transfer of heat as it bakes the porcelain to a very dense consistency. After all the layers have been applied, a technician textures the surface with a sharp tool. Then she sculpts it to give it tooth-like contours. Finally, she brushes on a clear ceramic glaze, which mimics the look of tooth enamel. Ceramic crowns like these take about 5 days to make. They'll look and function just like any other tooth, and no one need ever know the secret behind that beautiful smile. High-performance engines are technology-packed marvels that are the result of exacting design, modern engineering, and a constant need for innovation. Producing them requires the skills of many highly trained technicians. It's the lucky few that will get to enjoy the performance and thrills these engines can provide. Under the hood of this car is the latest in a long line of performance engines, legendary as much for their power as their looks. Each generation of engine delivers an increase in power and a reduction in weight, meaning today's engines consume less fuel and produce less CO2. At the heart of every engine is the engine block. It begins with a set of molds, cast from a mixture of special sand and resin. Technicians glue the mold parts together. Using a hand file, they make final adjustments by sculpting the sand mold down to the finest detail. An automated machine releases molten aluminum into the mold. After a cooling period, the machine releases the part from the mold. They must remove all the sand, which form the hollow spaces inside the engine. They spray wash the cylinder head to clear away any remaining debris. Technicians now begin to pre-assemble the cylinder head and intake manifold. Every part of the engine, such as this cylinder head, is made from aluminum. Expensive, but lightweight. Here, robots immerse valve guides in liquid hydrogen. This causes them to contract so they can be easily inserted into the cylinder heads. As the valve guides warm up, they expand slightly, which holds them in place permanently. One set of valves lets fuel into the cylinder. The other lets exhaust out. With a blast of pressurized air, workers verify that the manifold's air intake passages have been properly formed. Using a specially made tool, they verify the exact dimension of each valve. They visually inspect each cylinder head for debris and minor faults. If it passes, a worker tags it with an ID plate. Here, technicians insert the valves into position, then test their movement. Next, they machine the crankshaft down to its final specifications, and the entire assembly is positioned in the engine block. A technician lubricates the cylinder liners, then inserts them into the cylinders. They tap the liners into position with a rubber mallet. Then, using a bit of lubricant, they insert the pistons and connecting rods into each cylinder. With the aid of an automatic torque gun, technicians secure the connecting rods to the crankshaft, then verify the crankshaft spacing. Next, workers position and bolt in the valve cover. Then they install the air intake manifold on top of the engine and attach the fuel injection system. They hook up the finished engine to a machine called a dynamometer, which measures every aspect of engine performance down to the smallest detail. And now for the ultimate test, the road test.